So a South African and a Texan walks into a conference room. It's not a joke, it's happening now. I'm Corneil du Plessis, and this is my colleague and co-lead on Spring Cloud Dataflow, Chris Bono. Chris, please tell us a little bit about yourself.
Chris Bono, I'm the Texan in the Joker, and me and Corneil work on the same team. Spend a lot of time on Spring Cloud Dataflow, Spring Cloud Stream applications, and some Spring Pulsar as well.
Thanks, Chris. Yeah, I've been doing Java since 1995, and my applications have been in production since 98. And I started using Spring in 2004. So I have a lot of damage, but I'm going to inflict that on you. Today I'd like to talk to you about Spring Cloud Dataflow. I'm going to give you an overview with specific focus on Spring Cloud Stream, and we're going to dive in on developing Stream applications. And then hopefully we can answer all your questions. So what is Spring Cloud Dataflow? It is a microservice-based enterprise application integration platform for delivering tasks, batch jobs, and streams, and deploying, managing, and monitoring them on different platforms, such as Cloud Foundry, Kubernetes, or you can put everything on one machine if you want and just run a collection of local applications. And you can get observability via Micrometer and a host of registries for various observability platforms like Prometheus and Wavefront and InfluxDB. And if I haven't mentioned your product, I'm sorry. But let's jump in. This is an example of a Stream DSL. And if you look at the legend, you'll see there's some words are in black, some are in blue, and some are in light blue, teal. That's what they tell me. And it looks a lot like a Unix command line piping commands from one to the other. So the black words are the names of Stream applications. The blue words are the names of explicit destinations. And the light blue are labels, so that you can reuse or use the same application in different contexts and give it different properties. So here's an example of a relatively complex stream, but let's zoom in a bit. So when you define a DSL, you can also get a graphical depiction, or you can use the graphical mechanism to build your DSL. So here we have an example of a file source going to a splitter, which divides a message up into multiple messages based on a delimiter. And you can use a transform to transform CSV to JSON if you want, and put that on a destination. Or you can have an HTTP source deliver onto the same destination. And, and then at the bottom there, it continues onto a filter that decides which messages continue. And then you can have an aggregator, which will aggregate messages, and it will use some backing store to do the aggregation. And then you can put that on a destination, and from there you can go to a JDBC sync, and you can go to another transform and onto a WebSocket. So when you deploy this, it breaks it down in a collection of simple streams that you can manage separately. So here's an example of how that breakdown would look like. And we can do a similar thing with tasks. So you have a collection of batch jobs, and one of the most difficult things is to run this job and then that job, and we want to run two in parallel, and then when they're both finished, we want to continue. And we have a mechanism for you to orchestrate that without bringing any of that complexity into your batch application. Your batch application can just focus on doing what it does. You can visualize what's happening so that ops people don't hate you I'm bringing a new application to production, no, there's going to be observability. You can see if you get stream throughput, and you can find the bottlenecks, you can find problem areas on your streams and your tasks, and it's easy to manage and monitor. Now, how did we build this thing? We're part of the Spring team, and we are using the Spring ecosystem. So we are a consumer of the most of the Spring ecosystem. So on the one hand, the Spring applications are Spring Boot applications, and we leverage Spring Cloud to bring you Spring Cloud Task and Spring Cloud Stream. So one of the two most popular and most used Spring Cloud Stream implementations is on top of Rabbit and on top of Kafka. Sorry, I jumped forward. In the middle there, you'll see Spring Batch and Spring Integration. And on the left, you'll see the very important Spring Security. And Spring Data is how data flow persists the state of all these jobs so that you don't have to worry about it. So we are a Spring user, and we understand the ecosystem. And now we allow you to bring your Spring application and participate in an orchestration of stream applications or task and batch applications. And we take away a lot of the complexity. So what is it that we ship? So you can interact with data flow via a UI, or you can use the REST client and the REST interface to manipulate data flow, or you can use the shell, which you can either script or you can use interactively. It even has completion that makes it easy to use. At the heart of it is the data flow server, where everything that you define and set up and want to take place gets stored and managed. You can export that and take it into production so that you don't have to repeat it in production. And you have the skipper server. The skipper server is the one that actually manages this deployment of streams. And then you need to use some messaging middleware. As I said, we usually use one of Rabbit or Kafka, depending on what we need to do. And this is the ecosystem in a nutshell. There's also a large collection of prepackaged stream applications that we maintain. But if you go look at the code, you'll see that we are just taking Spring Integration and using it to provide streams capabilities. So when we create an HTTP source, we're using Spring Integration to create an HTTP source. So we leverage Spring Integration to do the heavy lifting and to take care of all the details. And we literally just make it behave in a certain way. Now, let's look at some of these applications that are interesting. I mentioned the aggregator. So that's something that, functionality that you might need, but why would you go and build it if you can configure something and it does the aggregation for you? We have a data flow task launcher. So that means that the end of a stream can result in the launch of a task. So the data flow task launcher is a sink that takes a message and with some configuration launches a specific task. So that means something happened and you want to trigger a task that does something, whether that is to create a document or send out a collection of emails or whatever. That's the kind of thing that you would do there. Filter. Filter allows you just provide an expression that decides what passes and what stops. You've seen HTTP can be a source. We have JDBC as a source or a sink. We have Splitter, which uses delimiters to separate your content into multiple messages. You can do a transform. or you can bring your own application. And this is what we want to show you today. So I'm going to hand over to my colleague and friend Chris to teach you how to create your own stream application.
Thanks, Corneil.
Thank you, Chris.
So when we say stream application, what we're really talking about, a stream application is a Spring Boot, Spring Cloud Stream microservice that produces and consumes events. And so then when we talk about a stream, we take those stream applications, we wire them together, string them together into a definition to do something interesting for your business. These alone are not interesting, a file sync, like who cares? But whenever you, like we started off with that complicated stream to show that you can actually do some interesting things with it. And let's go into here. So you've heard source, processor, and sync. These are common terms. And you know, if you look left, these are the events left to right. It looks like source goes to processor, goes to sync. But really what's happening is it's an indirect communication. The source writes to the bus. The processor picks it up, does something, writes back to the bus. The consumer picks up from the bus. And so you get the idea of this to and fro, and those arrows, writing those arrows, like I don't want to do that. That's writing to or from Kafka or Rabbit, and I would prefer to let somebody else do that. And so what we leverage Spring Cloud Stream because Spring Cloud Stream is really good at that. It has the concept of binders, and so it knows how to take a message and send it to the bus or to the queue. For Rabbit, it's an exchange. For Kafka, it's a topic. It handles all the errors for us. And so it really lets us abstract out any type of business logic. The other really amazing piece of it, it sits on top of Spring Cloud Function. And so if you think of source, processor, and sync, there's a mapping to Java util functions. And so let's look at the source. Oh, well, let's look at Spring Cloud Stream instead for a second. This is just kind of talking about this is the architecture and the components for Spring Cloud Stream. The binders is right on top of the middleware, and that's really what I was talking about right there. And so let's take a supplier, a Java util supplier. This is a POJO function, a POJO supplier. It returns something. We don't care. We literally do not care what's inside these functions that we go. You create the signature. What comes out of the supplier is that arrow down to the messaging bus. And who's doing it? Not me. Also, Java util function. You see the input parameter? That's the arrow coming up. Do something, the output parameter, that's the arrow going down. There's no Kafka code here, there's no Rabbit code here. It's somewhere, but it's not here. You don't care about it. Likewise, the consumer, Java util consumer. Give me something and I'll do something with it. And so these in alone of themselves are not super interesting, but each one of those pieces that Corneil started off with arrows and boxes and stuff, it's one of these. And so it's got to know where to go, where those arrows end, where one begins. How do I pick up stuff off the bus? There is some configuration behind the scenes, and Spring Cloud Stream and Function have this naming convention. We won't go too much into this right now, but you can see it's the name of the function with in or out, saying it's an input or output, and 0 or 1. We're going to go through and actually code a couple of these up here in a minute, and so we'll see more of it. So how do I build my own custom stream app? All those prepackaged apps where the screen came up and there were so many of these words on the screen, those are stream apps that me and Corneil and then some people in the Spring Cloud Stream and Spring integration team maintain. They've been around for a while. They're pretty good little building blocks. What if you want to get your own building block in there? And we haven't showed, like, where are these things? Whenever you pull up, when we run data flow in the UI, whenever we go to define a stream, there will be a palette on the left, if you will, of building blocks that you can use to string these definitions together. All those things that Corneil was showing you, I'll show you in a second, they'll pop up, they'll be there, you can build a stream with them. But say we want to get our own stream, and that's the common thing that something close to my business, I would want to create a custom stream app so that other people in my org could use these blocks as well. And so step one is to create the Spring Boot app, Spring Cloud Stream app, run it locally, make sure it works. No need to go further if it's not working. Like, you don't ship up if there's a compile error. Publish to Maven or Docker. And so those are supported formats that we accept. We're going to do Maven today just because it's local, it's easy. If you're running on Kubernetes, it'll be Docker, of course. And after that, after the artifact and we have some coordinates, then we tell Dataflow, hey, I have a source, a sink, or a processor, and it's located here, and here's its name. And from that point on, when the UI comes up, then Dataflow says, here, you can use this. And then we go through, create a stream def, and deploy it. All right, let's do this part. This is the fun part. I'm going to start up MariaDB. I have Docker running. What's up? I'm going to start up Rabbit. We're going to use Rabbit as our messaging middleware. I've already pulled down Dataflow Server and Dataflow Skipper. We're going to keep this simple. Let's see. Thank you. I can see it. It works on my machine. Yeah, thank you. This happened yesterday. Let me see here.
I'm going to mirror mode.
Yeah, what's that? Use slideshow? No, not that. Okay. Okay. Escape works always. Okay. It was just me typing in a terminal anyways. I just started up Maria and Rabbit, and then I'm going to start up Dataflow. And then I'm going to come over here, and I'm going to start up Skipper. These were the pieces Corneil was talking about. Okay. And so if I look over here, you'll see I have in Docker, in Docker Compose desktop, I have Rabbit, Maria.
Or might go full screen on this.
Yeah, I will whenever I think right now it's okay. Make it bigger. Okay, so that's not an interesting part. That's just getting everything up and running so we can do something with it. Okay. How do we create a Spring Cloud Stream app? We use Start Spring IO. Yeah, bear with me on the font size here. It's pretty small. If Start Spring IO, if y'all haven't used it, it's an excellent way to bootstrap your Spring-based apps. Usually you can do it, the UI on the web looks really nice, but there's also a plugin directly here in IntelliJ, and you don't have to go and download and export, so we're going to go this route today. Let's call this, oh man, Suite User, and it'll be under VMware Explore 2023, Maven, Suite Streams, and Suite User. Okay, Java 17, Maven, we're going to go with this for defaults. We're going to pick Stream, Spring Cloud Stream. We're going to pick Rabbit. And the way that it knows how to use Kafka or Rabbit, of course, is through Spring Boot auto configuration. It sees one or the other on the class path and acts accordingly. And this is all we need. And so we have a shell for our application. I'll bump the font size up when we get here in the code. Let me see. All right. Let's do this. Let's go in now. I know this is going to be the user source. What we're going to do is we're going to create a source app that's going to randomly, every second, give a new user. We're going to use Faker to create some data, and it's going to source in user events. Then we're going to create a custom processor that's going to take that user event, attribute a random tier to it, and create a registered user. So the source in is going to go into the processor and then go back down, and we'll tie it in with a log that just sends out to the console. Is that legible, or is it need to be bigger? Let me see. Okay, so what I'm doing here is I know ahead of time that I have to bring in, excuse me, Faker. I'm going to use some. If you haven't used Java Faker, it's pretty cool tool to generate random data. Okay, so let's start with a user. Here's our user. It's a record. It has a UID and an email address, right? And so now what we want to do is create a supplier, right? Supplier of a what? User. And let's call this new user, okay? What do we return out of here? We don't care. We're going to return a user, though, today. Let me step out here for a second. Go up here, private Faker, new Faker. So monotonous. Oh, I gotta reload Maven so it sees it. Okay. Faker.internet .uuid, faker.internet.email address. Cool. Is that it? What's it complaining about? Oh, how about a new, yeah. Okay, cool. So at this point, we've created a supplier that spits out a user, a new random user, right? Great. And so what do we need to do to configure this? I'm going to ditch the properties and move to YAML. Via IntelliJ Live templates, I've spared you the agony of watching me type YAML. So let's do source bindings. These are those bindings that we talked about, and so it's basically saying, okay, for the supplier's output of the new user function, let's write it to the new user topic. And so I'm gonna make this a little bigger. Okay. So the theory is that if I push the play button, let me do something else so that we can see the theory, right? So let's say var user equals new user, return user, and then I want to, don't do this at home, it's just this out. Okay. This way we can prove when we run it locally that it's doing something, because we don't obviously have time to write the test today here within here. Okay, let's see what happens.
We don't have time to write the test. I've heard that excuse before.
Well, as soon as I said that, you always have the time to run the test. Actually, if you say we're not right, if you ever see a line of code that says we're skipping unit tests so that we can move faster, run. Okay, so it's doing what we said. It's spitting out these users and it's writing them to a Rabbit exchange. And so at this point, it compiles. Everything's good. I'm pretty satisfied that this one is all right. So I'm going to do what that step was. I'm going to ls. I'm going to go to suite user. I'm pretty sure it's already in my Maven repo. I'm going to go ahead and do it anyways, doing a Maven install real quick. And then so now that's step one. That's the user app. Let's go ahead and let's go back in and create another project. We will call it Suite Processor. Same place, Java, Maven, com.suite streams. This part is just watching me typing, but it's fun when we get in the UI and start stringing them together, so hang in there. Suite stream, suite processor, okay. Next, again, stream, and then again, Rabbit. How are we on time? 22, nice, okay. Continue. Okay, here we go. Again, we don't need to adjust dependencies here because we're not using Faker in this one. And let me see how this screen is on real estate. Yeah, I think everybody can see that. Okay, so again, we would share a common library usually that has the user object in here for demo purposes. We're just duplicating the user record. We're going to duplicate the register.
Aren't you adding an indicator about the registration?
What's that?
Aren't you adding another field?
One sec.
There's registered user. Okay.
Got it. That's sweet.
So you're transforming a user into a registered user.
And so what we're doing is we're going to create a what for a processor? A Java util function. It's going to be function of a user is coming in from the bus. We're going to randomly attribute a tier to it and call it a registered user and write it out somewhere else for somebody else to act upon. And so here we go, function. Let's call this process user. Let's do this. Let's say return user. We're going to do a sysout so we can look at the logs again. Let's do var reg user equals new registered user of user. Bear with me. Don't do this at home either. It's not a really random number, but it is a demo, assuming I can type. Okay. And we're going to do tier.values of ram.nextInt, tier.values.length. Okay. One. Okay. We're going to create a register user, log it, and then spit it back out so that somebody can put it on the messaging bus. I think that's it. What are we forgetting? The config. I think one day we'll start Spring IO's default as application properties. I think one day it'll switch to YAML, I hope. It's the first thing I do usually. Okay, and so suite processor bindings. This one has two bindings, as you can see. If we dig in a little bit, Spring Cloud Stream bindings input, the destination, this is new user. That's where we are dropping from the source. And then output, we're gonna put it on something called registered user. And then we're gonna wire this up on the bus for a simple log sync to tell us that it got it. And the next part is, let's go ahead and do what I said on step 2 and run it locally to make sure there's no little minor errors before we go any further. And you will see nothing because this stream is starving, we're not feeding it, but this is just a sanity check that I didn't miss a key or a character somewhere. Okay, and if I come back over here to Suite Processor, and I do Maven clean install. Okay, it's up in M2 repository, which I'm pretty sure it was already there. I just don't want to have it not work because I didn't do that. Okay, so at this point we have, if we go back to our list, we've created the apps, we've tested them, and then now we put them somewhere in the Maven repository. The next thing we need to do is come in and tell data flow, and so localhost dashboard. Okay, this is the data flow admin UI that one of the ways to interact with that data flow. And I said we would load up the stream applications that were on that page, all the little building blocks that ship. Let's go ahead and just look at them. We're not going to use them other than the log sync, but there you go. You get an idea of them, and so you can look at all the processors, all the sources, filter by them. There's some information. Here's the version of the artifact. Here's the version of boot it's using, 2.x. These are all 2.x based boot apps. The ones we did, of course, are 3. And so now what we want to do is come over here and add our applications. Let's say suite user. It is a source running Spring Boot 3. The URI is Maven. Okay, com.suite streams. I better go look. Hold on. Let's see, suite user, what was its artifact? Okay, suite users, com suite streams, suite user. Okay, com suite streams, and then suite user, yeah, that's it. Okay. Again, also there's this metadata URI. Whenever you create it, we didn't cover this, but you always want to also create this metadata URI. And there's a properties file you can include in your app that says, hey, these are my configuration properties we use. And so that way when it comes up in the UI, like I'm about to show you, it'll pre-populate with all your properties that your application supports, which is nice because if you have a toolbox of properties, you don't want to go try to dig around in the reference guide to see what they support. And so if we pop over here and I start by Spring Boot, there we go. You see our sources at the top and it's a 3x Spring Boot source. One more, let's do our processor. This is Suite Processor. It is a processor running Spring Boot 3. Its coordinates are maven com.suite streams :suite processor. Okay, I think that's it. Import it. And really, there's very little that's happened at this point. We've just told Dataflow, hey, I have a processor and a source. It's located over there. You can use it. And you see that it's in the toolbox now. And so let's do something with it. This is the stream definition. This is the blueprint. By creating a definition, it's literally a blueprint. There are no services start up. And so this is all the DSL that Corneil was showing you. And mine's going to be drastically simpler. It's going to say suite user. Let me see. Can y'all see that? Okay. Suite user. Oh, don't do that. Pipe. Send it to suite processor. And let's terminate it and log it in the log sync. And so that's it. This is that picture we started off with the 3. To the bus, from the bus, to the bus, from the bus. Let's create it. Let's call it Suite 3. Yeah, it's clever. Okay. Okay, undeployed. If you drill in a bit, you can see it's not that exciting. There's not much to it yet. It's just a definition. And live demo, are you going to work? Let's see. Let's deploy it. Oh, yeah. Okay, so let's give it a second to deploy. Right now what it's happening is there's a layer that we haven't talked about called Spring Cloud Deployer. And so when Cornell said that we can write to Cloud Foundry, Tanzu Application Service, or to Kubernetes or local. I'm doing local, obviously, but that's abstracted out. When the stream deploys, something knows how to go, put it in the right spot, and we'll see as Java processes. Did it deploy? Yes, it did. And so let's jump in here a little bit. There are some more details here. We have some deployment info and the runtime. Let's see what our Suite user source, it looks like its logs. There's boot 3.1. And you can tell it's doing those sysouts of random users with emails. And let's close that. And so let's look at the second hop in the pipeline, which is the processor. 3.1.2 boot, and there it goes. It's creating registered users with this, tier at the end of them. Let's close that. And finally, was somebody else, an old boot 2.6 app, the log sync, was it able to do the same and get them and spit them out? Yep. That's it. And so what we just did was, how do I create my own custom apps? We just did it. It's pretty straightforward. That's what Dataflow, if there's a shop and they use their Spring Cloud Stream users and Spring Task, we can do the same thing for Spring Task and Spring Batch, just like what we just did for Spring Cloud Stream-based apps. And the model's the same. It's the same steps. It's the same UI. Slightly different things you can do, but that is it, I believe. There's some other operations. You can update the stream, change the versions. Oh, let's just do this while we're here. We got a minute or two. No, let's don't. I was going to switch the log to the 3.2 version, the boot 3 version, but I need the coordinates to register, and I don't. I'm going to get off the keyboard. I might derail the whole thing here. And I think, let's jump back to the presentation. All right. Questions and answers. This is maybe, yeah, go ahead. Let's see if we can all hear you. Yes.
Yes.
Processor as well as the supplier that will be defined with, they have different names. How they are replicating. This guy is publishing to some queues and the other guy is listening to some other queues.
Yep. There's one piece in there in the properties that we didn't talk about. There's an alias, data flows.
Yes, I think let's just repeat it for the audience. So what he asked is, if you have that stream, how are these things named so that who's listening to what, who's reading what, and because at the moment it seems like magic. But what would have happened here is, it would have, what it does is it now creates a queue, in this case, because there's a line, there's no tab, and the queue will be based on the stream name, and then the name of the source. So there'll be a name called stream3-new-user in Kafka. So Spring Cloud Dataflow makes those decisions.
There's another missing piece, and look at that YAML a little closer. We alias the function name to input output.
Yes.
Data flow says input, output, and that's the
So it
missing.
creates both sides and it hooks it up to the.
We
So
alienate
there's
it off
every
that.
line that you see in your stream graphical representation will be a queue or a topic, or in the case of Rabbit, an exchange. But and it will be named after the stream and the two sides, or on the left-hand side. But if you now pipe two, and you remember our very first diagram, we had a colon and a name as a destination. So now that name is going to be stream and this name in there. Or you can actually override that when you create the deployment. So you can connect to existing topics that you have created, but then the responsibility is in your hands to make sure that whether it's a queue or a topic, that you are dealing with that properly. If you let Dataflow do its thing, it's going to behave in a very specific way. Okay. But the bottom line is, if you look at Rabbit, you will see something that matches what you just created.
We are migrating our Spring integration to Spring Cloud Stream.
Nice, nice.
Now this is another layer of abstractions.
Yes.
Got it.
So what you'll see is there's a Rabbit source that you can use with Kafka, or there's a Kafka source that you can use with Rabbit. So now you can build that bridge. Or you can use it, you've got a Rabbit bus, but you've got existing topics or stuff that you don't want to change, and now you use the proper source for that, or sync for that, so you know you're getting out of the old world without changing the old world.
I'm trying to see how Spring Batch and this overlap functionality. Because Spring Batch is for long-running jobs. And because Kafka and Yahoo provide the persistence there, this can be used for long-running job work. Because you can have sources, dump stuff, and queues which you persist. So it can run for hours or days, just like Spring Batch. So what drives which one decision do I choose compared to Spring Batch versus this?
Well, so data flow, I'll say that if you have Spring Cloud Tasks, Spring Batch apps, or Spring Cloud Stream apps, I could say you don't need data flow, and that's like why would you say that? You work on data flow. The point is, it makes orchestrating and managing those things easier. And so you can definitely, whether you need to use a Spring, which one of those you need to use, it was the same decision you would make if you didn't know anything about data flow. And you would just say, when would I do a batch versus a task versus a stream? And so my batch might run for a long time. Streams are meant to sit there and process data until they die. And so Spring Batch will handle the long-living nature of the state and recovery and all of those things. Did I answer the question, or is there something else? And if we can also catch up afterwards, and I would love to talk more. Yeah.
Maurits.
Okay, then just,
Yes.
no, it's on. Okay, great. And your example, this producer function, how often is it called?
By default, it's a minute. You didn't see there's a piece of Spring integration every second. Yeah, the other minute. Every second.
Okay, there's a configuration which essentially
Absolutely.
says, okay, and what happens if I block this supplier? It just waits until it comes back.
If you block it.
Yeah, if I take a long-running application which just collects data from somewhere.
Yeah, if you have I'm not sure exactly what it would do. Like I have to go look and see exactly what the Spring integration piece is.
Yeah, so basically,
Don't do
let's
that.
say you have a FTP supplier.
Yeah.
So
Yeah.
it needs to look and decide if there's a file that it's going to turn into a message. So it will, by default, look every second. But now I don't want it to look every second. Maybe you want to give it 15 seconds because there's going to be an upload. So now you can change that property as the default from 1 second to 15 seconds or whatever you want. And it's a standard Spring integration property. But now when you've built your supplier or your source, you add to the configuration that I'm using these Spring Cloud properties. So you go and look in the documentation which property class it is, and you put that in the property file, and you put your own other properties there, and you declare those property classes. And then if you use the metadata plugin, it'll create a little jar that Dataflow can read. And then when you're doing that deployment, you click on edit and you see these properties that you can change when you deploy, and now you can configure your application from that.
You could also have a reactive supplier.
Yes.
Flux is also supported, but yeah.
Cool, thank you.
Yeah, yep. Does y'all mind coming to the microphone? It'd probably be better if everybody could hear you. Sorry.
How about a queue behind the mic?
So how do you manage like the users, the Kafka users, and the permissions for those users in this model?
How do we manage the Kafka?
Like, so for our applications, we have real strict RBAC requirements essentially for what applications can kind of write and read from different topics in our Kafka.
Right, so I got it. So there's a whole slew of, the same Kafka properties that you pass in on your, forget about this, you have a Kafka clients app, and you know what your YAML looks like, right, with that. A bunch of properties to help to point to where the credentials are, point where that, there's an extension to the bindings properties, and you would just drop it in under there. So there's a whole layer of, we can abstract out as much of the properties as we can that makes sense across the lowest common denominator between Kafka and Rabbit, but clearly there's a lot of other properties that they diverge, and you can configure that there.
Yeah, so in the section for configuring Skipper, you can actually drop in and go to, there's a defaults. So now you set the defaults for all deployed streams. There's how you talk to Kafka, and you don't have to touch that unless you've got a choice variation from the default.
But you can say like this producer uses this user.
Yes.
Yeah. As fine-grained or as coarse as you need to do it. Yep.
Yeah, how do you support graceful undeploying of things so you don't drop in transit messages on the floor?
Graceful undeploy. That's a good question.
Look, because a stream is this long-running thing, so it's not like a task that you say, I want you to shut down, so because then you're interrupting what it's doing. In the case of a stream, well, what's the definition of a graceful undeploy? We want it to stop working. So all it's going to do is it's going to take down those various applications. So it's not like we have something to shut off the sink and then take them all down. We knock them all down at once. So you'll see if you do an undeploy, it's relatively quickly, but a stream is designed to be deployed, and now we want it to stay running forever. If something stops, something went wrong, unless we've asked it to stop. So that is the model at the moment. If you have a specific use case, I'd love to hear so that we can explore that and see if there is something that we can do to give you a graceful or a controlled undeployment.
Pause, like you want to pause and then do something down the stream. When you have something that's like 15 nodes,
Yeah, exactly.
well, what's going to happen? Yeah, and so we actually have something on the backlog. We didn't end up going through it, but it was basically the ability to pause gracefully so that you can do something
So
like
what
this.
would happen is it would talk to each of the nodes and say, stop what you're doing, and then you can roll out an update or undeploy and deploy again. What you need to remember is it's going to take down queues that if you're changing names, and that queue name is not going to exist again. So there's a lot of what ifs that have to be addressed to get that. So at the moment, it's when you say destroy, we're taking it all down, and we're assuming that you're happy that that's going to happen. But I'd love to hear if you've got some extra ideas. Our time is up.
What's up, Sobi?
Sobi.
Yeah, you won't lose data, right? They might not be the most graceful shutdown, but you will not lose data. Yeah.
thank you everybody
Yep.
for joining us.
Yeah.
And if you have something more, hit us up in the hallway track.
Yeah. So we'll put it up there.